Lots of questions regarding positive, negative coterminal angles. I think a lot of the weirdness people are still freaking out with some of that. Yes, sir. Yeah, just have to watch the video there. What's happening with a lot of this stuff is people are making kind of silly mistakes here and there. You're over a lot more overthinking. Okay. So let's take a look at a few of the examples and see how we were doing. If there's particulars, because today it kind of starts to come back together of kind of like why everything is working. Okay. So were there particulars you wanted to see in those sets? Sure.
Just as an example to represent the positive and negative terminal angles, can you just do 18?
Will you tell me what the angles were?
Negative 130 degrees.
Okay. So again, as we're trying to find positive and negative coterminal angles, first thing I want you guys to always do, draw it. Okay? Draw it, figure out what quadrant you lie in, then figure out your reference angle. Reference angles are always how far you are off of the x-axis. Okay? So from here, negative 130 means I start at 0 and I'm coming past 90, I'm over here. I'm 50 degrees away from 180, or negative 180, okay? I don't remember what number it was, okay? So that's just telling me my reference, okay? Yes, sir?
So would that be the answer?
No. Well, it's just give me a reference point for right now. Reference angles are become kind of important here in a little bit. That's why we're just practicing it, okay? We're not using them with this per se, but now when I go to get my positive and negatives, I want to end up in the same spot going the positive direction. Well, that's 180 plus 50. So that's where I'm getting that. That's why I'm using that little buffer there of figuring out how far am I away from it. So add that together, I believe that's what, 230? So there's your positive. Your negative coterminal, well, since the original negative angle was within one revolution, I just go around again to hit it. Okay? So basically I go around one more time, starting here, and I wind up back there. So I'm going negative 360 and another negative 130, so it'd be negative 490, I believe.
Isn't the positive still in one revolution? So you would have to go.
What do you mean?
When you said since the negatives, you hit the negative within one revolution, you have to go the extra. So would we have to do the same for the positive?
No, because when you start, whether it's positive or negative, if your original angle is within one revolution, all you do is add and subtract 360. Yeah. It's when it's beyond you have to do other stuff. Okay. Yes, sir. Great conversation. We do. You and I do. So this is good. It's good for us. It's like bonding. Yes, sir. Hold up, guys. No, and I think in that section you're looking at there is just draw the angle, find the reference angle. That's all you guys do. You guys can practice. I just want you guys to practice. How do I get to my positive? Around to it. I go 180 and I went down another 50 years. Okay. Yes, ma'am. Ladies and gentlemen, come on. What always happens with you?
I'm sorry. I just asked the that happens with the reference. That's enough reference.
I'm sorry, what do you mean by reference?
Like, what's the question?
The question was positive or negative coterminal. I'm using the reference angle to help myself with all that.
Okay. I thought you were talking about this one. These and this one. You're just
Right. Just draw it. Yep.
Then can you do number?
What does it say?
It's 13 pi over 6.
13 pi over 6. And this one was just draw the angle?
Find the reference.
Okay. So this is 30, you said?
Yeah.
30. It's just draw the angle, find the reference. 13 pi over 6. Is 13 over 6 more or less than a revolution?
More.
It's more. Okay? So what happens is, in terms of sixths, if I can say that, it would be, to go all the way around would be 12 sixths. Okay? And it's 1 sixth more. So we just go all the way around, there's 12 sixths, up a sixth. So my reference angle is pi over 6. I went past the x-axis, pi over 6. That was 30.
Can you do like a degree one that's just larger, like than 360?
Yeah, you know what?
600.
Is that just draw the angle, find the reference, or is it a plus or minus, get positive and negatives? Okay, so 6, you said 610?
Yeah.
Okay, so 610 degrees, is that, obviously that's beyond 1 revolution. Is it beyond 2 revolutions?
No.
No, that would be 720 degrees. Are we okay with that? Yes. Okay, so what we do is, excuse me, we know that it's 1 full way around, that's 360 degrees. I need to figure out how many more degrees I have to go to place it. So what I would do is just subtract 360 to see what's left over, because I've already spun that far. And I do that, what, 250 then? Okay, 250. Well, if I continue on, here's 180. Okay, figure out how much more I gotta go. And then I have to stop 70 degrees. Am I going to be beyond the vertical? No. So I have to move off of this axis, because I've got to another 180, 70 degrees more. So this 70 degrees would be my reference angles. How far has that one gone off the x-axis? Okay. Now, what?
I was wondering about the positive and negative.
Okay, so when you think about what we did here, by figuring out how far you have to go, we moved it, we backed out the 360. This 250 degrees was the would be within 1 revolution. And it shares the same thing as the 610 because I just went around 1 full revolution. This is the positive. Okay? To get the negative, I want to think about going the other direction. I have to come to here. Now, if I went the whole way from 0 to 180, it would be negative 180 degrees. I stopped 70 degrees short. How far did I go? 110, yep. Negative 110. Okay. That's how that stuff works. Okay. Whenever your angle starts beyond a revolution, whether it's positive or it's negative, you move it to within 1, and that's your first positive, or it could be your first negative, depending on whatever it is, and then you just go the other direction. Okay. What does it say? Area of the sector. What's the radius and the angle? 90 degrees. Area of the sector. Area of the sector is 1/2 radius squared theta, where theta is in radians. Okay. When I convert to radians, that means I have to take my 90 over 180, slap the pi next to it. Yes, sir.
Wait, why are you doing 1/2 r squared theta when you just do r squared theta times 90 over 60?
It's the same thing. I know.
Well, yeah, it's the same thing.
I'm just using the formula that this textbook uses. That's all I'm doing. It's the same thing. I'm not going to yell at you whichever way you go. Okay. So now here, you know it's still 81 is your r squared. You still have a 1/2, right? What's 90 over 180?
1/2.
So that becomes 1/2. What's 1/2 times 1/2?
4.
So it's 81 pi, oops, over 4. What's that? Yes, sir. That's a giant circle. It's 9 kilometers over radius. If you think about it, what was it? A 10K is 5.5 miles. Is that about right? So that's about 5 miles for a radius. That's a 10-mile diameter circle. What's that? Yes. Yes. How old are you at? What? Read it.
The length of the arc, the angle is 5.4.
Is what?
9.
The units that Kuda uses the dumbest units in the world. So arc length. So arc length was radius theta, if theta's in radians. Is that angle in radians?
Oh.
Yes. So it's 9 times 5 pi over 4, which is 45 pi over 4.
Just imagine these had word problems.
Why did you say
Don't do that again. Shame on you. Hang your head in shame. Look in the corner for 30 seconds.
Why did you say theta makes the weirdest problems?
They don't make weird problems, they're units. Because if you look at the units, it was like 9 miles for a radius. Are you serious? Is a circle with a radius of 9 miles? Come on, stupid.
Hey,
Yes,
this
sir.
is math. Anything.
So, can you just draw like a random angle on a thing, and then I'll ask my question.
Like,
Just
what do you...
draw a random XY grid and a random angle.
So,
Okay, so when, to find my positive and negatives, when do I know that I just go around, or when do I know that I have to go around another time?
Is that angle within 1 revolution?
Yes.
Okay, so you add 360, subtract 360.
Okay.
All right, now. Is that within 1 revolution? Oh, is it within 2 revolutions?
Well, no.
Because you think about it, here's one revolution, and then I did it again, 2 revolutions. So if I back that all the way out, what quadrant would your original angle be in? 4th quadrant, okay? So that 4th quadrant, it's negative. Will that negative angle be less than or greater than 90? Excuse me, between negative. So is it between 0 to negative 90? Is it between 0 to negative 90?
Yes.
That's where that would go. Okay. So think of this way. This could have been negative 20 because I spun around. So this original angle could have been negative 740. I went around once. There's negative 360. Went around again. There's negative 720. Drop it again. There's negative 740. By backing them out, this gets me to my original within 1 revolution. This becomes your negative angle. Okay? If I go positively then, I would just go the other direction and you would be very good. Yeah, 340.
So your negatives would be negative 20.
Yes, sir. Yep. If you are beyond if you're beyond 1 revolution, as soon as you get within 1 revolution, you are now at your positive or your negative, and then you just do it again to get the other. No, I like purple better. I think it looks nice.
So you set it up to be.
I can pick whatever color I want. I can make this screen black and make this white.
that would be bad. Oh, yes. So that's so the
Guys, enough.
so the angle of the first one that is like 70 degrees. That's constant already, right?
That's just the original angle.
So
If you're within, you add 360. If you're
70
within,
plus 360 is positive 70 minus 360. Okay.
yep, that's the rules. Yes, ma'am. Will you read me the angles and stuff, please? Is this one just say draw the angle by the reference angle? Okay. So 11 pi over 4. I want to immediately I want to convert that to a mixed number. 4 goes into 11 how many times? How many are left? 3. So this is 2 3/4 pi. Everybody okay with that? That means this is beyond a revolution. Okay? So was it positive or negative? Positive. So what I do is I start by drawing it. I know I have to go all around, make 1 little, 2 little. So we're at the 2 pi. Now, 3/4 pi, is that more or less than halfway? More. Okay, so it's going to go to the second quadrant. So we bring that around. how far am I off of to continue to make a full pi? There you go. So your reference angle here would be pi over 4. Okay. Reference angles are always how far you are off the x-axis. Always, 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 always. Okay. Yeah, whatever the theta value is going to be, whatever it is in radians. So if they give it to you in degrees, then you do the degree over 180 times pi. If it's in, like in this case, if it gave you 11 pi over 4, that's theta because it's in radians. Right? Did you try any of those yesterday? Yeah. Come on. You gotta do more work. I'm telling you since late, but which one? Read it.
I don't like the meters, radius.
Okay. Radius is that, find the arc length. Remember the formula is radius times theta, where theta is in radians. Convert 90 to radians, you get 90 over 180, slap a pi next to it, and then I have to take all that and multiply that by 10. What's 90 over 180? What's half of 10? 5 pi. Pi. So the area. Because the reason because of that is because you're thinking it's part of the circle. You have to do the whole circle versus just the circle. I read it.
Area of the center is, it gives you the angle of the whole circle except for the
Okay.
So that's 315.
Okay.
And the radius.
Okay. So that's 1/2 radius squared theta. So 315. 315 is how far away from 360? 45. So let's think of it this way. How many 45s does it take you to get around 360? 1, 2, 3, 4, 5, 6, 7, 8. How many of them did you just do? 7. So it's 7/4. 847 pi over 8. Is it 45 degrees? Isn't that pi over 4?
Yeah.
Right? So if I'm looking at it in terms of that, if I'm down pi over 4, reference angle wise, the whole way around is 8 over 4. That's 1/4 less. There's your radians.
Wait. Same with theta is again? What exactly the value of theta?
7 pi over 4.
Well, what part of it is?
What do you mean?
Is it just
315 over 180 times pi. Think of it in terms of 315 is 45 degrees from 360. 45 degrees is pi over 4. 360 is 8 pi over 4. 1/4 less is 7/4. Make math work easier for you. Okay. Ratio. 9 and pi over 3, okay? Last one, we got to get going on the rest of this stuff here. Radius is 9, theta is pi over 3. It's an area problem. 1/2 radius squared theta. Theta's in pi, you don't have to do anything to it. So you wind up with 1/2 times 81 times pi over 3. 3 goes into 81 27 times, so you get 27 pi over 2. Okay. So now we get into where everything kind of comes together. Okay? If you're having problems with these, those solutions are posted, you have to check them. You have to try them and check them. I cannot do 25 minutes of homework review every day, guys. All right? Cannot do that. So as we go through this, we start getting into trig functions of all the angles. And this kind of goes back to what we did in the first section of this trig trig unit when we started. Remember, we all jumped back into Pythagorean theorem, special right triangles, so elevation, depression, before we got to law signs and all that. One of the other things we did was this. If the cosine of theta was 5/7, I asked you guys, what's the cosecant of theta? Nope.
Oh no, because you.
Correct.
Yeah.
So, in this case here, what did you have to do when we set these things up?
Draw a triangle.
You drew a triangle, okay? Cosine is what over what? Okay? So, once you put your right angle in, does it matter which place, where you place theta?
No.
Nope. So, if I place theta here, I get 5/7. How do you find the missing side length if you know 2 out of the right triangle? What's 7 squared? What's 5 squared? Subtracted. What's the square root of 24? 2√6. Very good. 2√6. Okay? Now, when you get to here, you've got 2√6. Cosecant is the reciprocal function of what? Sine. So you have to find the sine of theta. So the sine of theta is opposite over hypotenuse. So the cosecant, would be hypotenuse over opposite. Then you have to rationalize. When you rationalize that, it's pretty quick. You get 7√6/12. Okay? As you go through. Now, when you did all that, that wasn't anything crazy. We knew that cosine had a reciprocal function. It was called secant. Sine's reciprocal was and then tangent's reciprocal is cotangent. So this generic idea allows us to get to something like this then. Where is this ordered pair located? Correct, -3, 4. Thank you, Captain. It will be on the board, yes, but second quadrant. Good. So, start XY grid. And we place it. Now I'm going to add some vocabulary here. The terminal side of an angle lies at the ordered pair -3 and 4. Yesterday, when we talked about terminal sides of angles, where was the vertex located? 0, 0, the origin. Then that vertex rotated to some position. Yes, you were just dealing with angles. We had degree symbols, we had pies, we knew where things were going. Today, I'm going to say that it ends there. Okay? So far, so good? Now, when we did that, that meant, since I'm saying that this, we're always going to say that these are a standard position, so we're going to say this was a positive angle to start with. It came over that direction. Where is its referencing? Yeah, you gotta spell like this. It's over here. It's over here. So the reference angle is this guy here. I'm going to place a theta there. So far, so good? Okay. Now, if I draw this here, it's a 90-degree angle. What's my opposite? A 4. What's my adjacent?
-3.
What's my hypotenuse? 5. Very good. Okay. We just used Pythagorean theorem to get that, didn't we? Okay, not too bad. Now, what's the cosine of that theta? -3/5. What's the sine of that theta? 4/5. What's the tangent of that theta?
4/-.
Yeah, either one is fine. Okay. What's the secant? Cosecant. And cotangent. Isn't that what? Go ahead, say it. Say it.
I thought you wrote sine first, and I thought it was secant, but then
Why didn't I put sine first?
because
What's that? Comes first in the alphabet, X or Y.
So it makes sense.
C.
You got something right?
Yeah. Why do we put negative 30?
It's negative direction, isn't it?
Yeah, but with the distance.
I'm not, but I want a different direction.
Oh, okay.
Okay, but it's directional. Same thing, think about an angle. An angle could be negative, just going in a different direction. A direction at an XY coordinate grid system can also be negative. All right. Quick, hide your stuff. Now, now, let's try this again. What quadrant? Third quadrant. Okay. Now, this one kind of sucks because it's negative 12 and negative 15. Are you going to mark all those little tick marks? No. No.
We're lazy. Yeah.
So I know it's placed right there. You okay with that? Terminal side places my vertex at the origin. I always draw these back to the x-axis. I always draw vertical back to the x-axis. No matter what quadrant I wind up in, I always go to the x-axis because now, where's my theta going to be? Because if you look at that, that's your reference angle. How far did you drop off of the x-axis? Exactly. What's your opposite? What's your y-coordinate?
Negative 12.
Your x-coordinate was? What's 12 squared? What's 15 squared? Add them together, we get 369. We have to square root that to get the hypotenuse, don't we? Okay. When you square root that, it's not clean. So we have to figure out what's the perfect square that goes into it. Notice right away, you see some 9s, don't you? 9 goes into 36 how many times? 4. 9 goes into 9 how many times? So how many times does 9 go into 369? 41. So the square root of this would be equal 3 root 41. Are you okay with that? Okay. Can't I still go through and list out all 6 of my trig functions?
Yes.
All right. So we start with cosine. Cosine is what over what? Adjacent over hypotenuse. My adjacent is the negative 12. My hypotenuse is the 3. 341, excuse me. Now, I'm going to do 2 things. I'm going to simplify and rationalize. Simplify first, the easy thing, it's just negative 4 over the root 41. And then when I rationalize this, you should be able to do this in your head now. It should be negative 4 root 41 over 41. Go to cosine, same thing. Okay? Cosine. I'm sorry, I meant sine. Excuse me, I just said big cosine. Negative 15 over 3 root 41. And now we have negative 5 root 41 over 41. What's tangent?
Opposite over adjacent.
So,
Negative 15 over negative
5/4. We okay with that?
12. Yes.
Now, I'm running out of space in this one slide here, so I'm going to split into 2 to do the reciprocals real quick. When you do reciprocal trig functions that have roots, you always go back to the unrationalized portion of it because it's easier. If I look at the unrationalized portion of cosine, it was negative 12 over 3 root 41. In other words, -4 over root 41. If I flip it, it's just negative root 41 over 4, isn't it? So you're secant. Always go back to the unrationalized part to do it. Otherwise, you got to re-rationalize and simplify, and it's just kind of a pain. Okay? Same thing with sine. Sine was originally -15 over the 3 root 41, which meant it was -5 over the root 41. Flip it, your cosecant becomes negative root 41 over 5. Cotangent is the easiest. What do you get? 4/5. Good. Now, there's rationale behind a lot of where this stuff is going. And we made mention of it first hour. I don't know if you guys wrote this down to remind yourselves of when this thing happens, but remember very beginning of the year, first hour said it was August 28th when I said this, so you probably don't remember it. It was a little bit warmer out. We said that, I always ask you guys, what comes first in the alphabet? X or Y? What comes first in the alphabet, sine or cosine? Cosine. If I look at my X values, when theta is placed here, what's always your adjacent? Your X. What's always your opposite? Y. What happens here is that we're going to wind up, and also, let me go back to this one real quick. So we're okay that this was some X value, this was some Y value. We called this was our hypotenuse, but eventually, no, we're not three-dimensional plane. Eventually, we're going to get into circles. Circles have what? Oh, I thought you were waving to somebody there. Radius. I'm going to call this my radius. Okay? I'm going to call that my radius. Now, as you go through this then, you'll start to see that, how did we find the radius? What did we do? We did Pythagorean theorem, right? But instead of a, b's, and c's, we did x squared, y squared equaled r squared. Wasn't our radius then x squared plus y squared, the square root of it was your radius? Well, yeah, but we're not doing arc length here because we don't know what theta is. I'm not worried about that. But if I think of it in terms of x, y's, and r's, what's cosine going to be? X over r. What's sine? What's tangent? Y over x. Because no matter where you're placed, if I'm placed here, isn't the vertical part always your y coordinate? Your part here is always your horizontal coordinate? Because no x's go horizontal, y's go vertical. Yes, sir. Yep. All right. Now, here's what happens then. I can say that the cosine of a theta is always x over r. The sine of theta is always y over r. The tangent is always y over x. And then you have your reciprocals. But it gets even crazier. It's even crazier if you start thinking about where things happen in the grid. This is always going to hold true. Okay? This is always going to hold true. And the next part is something you guys have been doing since you ever learned how to graph. All right? A little while ago, we had an ordered pair of, was it -12, -15? You guys told me it was what quadrant? The third quadrant, because what's x and y down there? They're both negative, okay? So if you go back and you start thinking about your x, y coordinate system, first quadrant, what's x? What's y? So are you guys okay if I say positive, positive? What's over here? So, if you're thinking of it in terms of x's and y's, your x value is your what? Your adjacent, correct?
Yeah.
Well, will your radius ever be negative?
No.
No, because you have to use Pythagorean theorem to find it. Was the hypotenuse of any triangle ever negative?
No.
No, because when you square something, it always becomes positive. So here's what happens then. If I'm in the first quadrant, what's my cosine always going to be? Positive. What's my sine always going to be? Positive. Cosine is positive, sine is positive. What happens when you get to the second quadrant? Cosine is negative, sine is. That's why law of sines works with the secondary triangle. Because that secondary triangle, you could have that obtuse angle. Remember how that obtuse angle shares the same reference angle as the first quadrant? That's why all of that works. So cosine is negative, sine is positive. What about the third quadrant? They're both negative. And then positive, negative. Now, think about tangents. Tangent was what over what? Opposite or adjacent. In terms of x's and y's, that was y over x, wasn't it?
Yeah.
Your sine over cosine. Okay, your sine over cosine. What's a positive divided by a positive? So tangent is positive. What's a positive divided by a negative? Tangent is negative. What's a negative divided by a negative? Positive. Oh, wasn't that what we did earlier? Tangent was 4/5, I think. And what's a negative divided by a positive? Negative. Now, if you have reciprocal functions, do the signs change with reciprocals? No. We're not talking slopes, we're not doing opposite reciprocals. We're just talking about reciprocals. You're just flipping fractions. So all the reciprocal functions follow the same pattern here as well. Okay? And the reason why all of this works is because once you place a theta, that opposite is always a y value. As that reflects to here, that theta value is the same reference angle as it was here, which means that y value is the same. As it reflects to here, that theta value is the same value going down to here, but what doesn't change now? The x value doesn't change because they're vertical of one another. And then as it goes back to here, that y value stays the same because they're horizontal to one another. Once you know a reference angle in the first quadrant, you can find it in all quadrants. That's why things can bounce and get different signs, SIGNs, and not SINE. I'll say that a lot because the signs, GNs, change all the time in these things, okay? That's where all this stuff gets us towards. And it all stems from, can you place something in the coordinate system, figure out the trig functions, and it also deals with, this is why I've been harping, reference angles. Reference angles will become your best friend, right? Yes, sir. You look like you're ready to ask me something. Yeah, you kept looking like you're about to say something.
Really? No.
Not yet? I did not have time to get through quadrantals in today, so that's no big deal. So in the 13.3, I've got 3 problems that are place the ordered pair in the coordinate system, right after 6 trig functions, and then the other ones are the get all your reference angles. Okay, get reference angles. So it should not be too difficult to work itself through. The main idea here, guys, is that if you understand where ordered pairs are placed, you understand how trig functions work. Because everything parallels itself. They're all kind of the same. This is where everything you guys have learned about graphs, everything you guys have learned about the very simple bit of trig, all start to melt together of why all of this works. We start to dip our toes into it, okay? Monday we'll finish 13-3 Tuesday. Between Tuesday, Wednesday, and Thursday, we'll finish up 13-4. We will quiz next Friday over these first non-calculator sections. Okay, so the reference angles and areas, coterminals, and then eventually as we get into find exact values. So it's been fun. Okay, questions so far?
Oh, wait, actually, yeah. When am I going to test that?
Once I get everybody to get them done, there's been I have over 30 makeup tests and quizzes to get between all of my classes because there's been so many people out and sick, field trips and everything. I just can't get them. I can't get people
Will
to
it be on the next test or whatever we do?
the law of science stuff. The law of science, I don't because it's not calculated anymore, so I don't bring that in. I won't see that again really until the final.
Okay, so you'll give it back. We have to see it in a test or
And that's what sucks. I mean, there's nothing I can't really help people being.
and they're all just like quizzes.
The hard.
So we're not going to take a test
We will.
over everything.
We will. But the steps that we take, of course, we're very the law of science.
Okay. Also, I have a question about that.
Makes it